All right, here we are on phase 2, processing. So we're going to turn to page 93 and look at the visual summary. This is where we're going to start looking for things to highlight. The rock record provides clues about changes to Earth's surface. Okay, rock record, that is one of our sections. So let's go ahead and highlight rock record. Clues about changes to the Earth's surface. Clues about changes. Okay, up here we say Earth's surface, and we see the word change. Also, the rock record is clues. So, did we ever actually use that word? No. So let's add that word in. We can use our pencil or a pen. Clues about changes. And now let's highlight that, or you could underline that or put little stars next to that. So we would say something like, the rock record gives us clues about changes to the Earth's surface. For example, the properties of rocks help us understand that similar layers or strata are being found in different parts of the world. I think it's really important that the youngest is on top and the oldest is on bottom, because that helps us with dating. So let's put D-A-T-I-N-G. Highlight that. And then I'm going to use my red pen to put stars, because we're highlighting a lot here. So I think the most important stuff is over here, that the rock record gives clues about changes. One of those clues is about how old something is, or dating it. The youngest things tend to be on top and the oldest things tend to be on the bottom. And then they're giving us clues about the Earth's surface. So I starred rock record, clues about changes, dating youngest oldest, and Earth's surface. That's what I'm going to use for my summary paragraph. Okay, next up, fossils preserved in sedimentary rock are the remains of once living plants and animals. Okay, we flip it over to fossil record. So fossils, they're found in sedimentary rock. They are evidence of organisms. Fossils from the same species have been found on different continents. Okay, same organisms, different continents. That was all the way down here in clues about the past. Good. Okay, I'm going to put red stars next to those, because that was straight from here. And I'm going to put little numbers next to them, actually, to help myself remember what order I want to talk about these things. So that's going to be a number 1. That's going to be a number 1. That's going to be a number 1 on the front. Flip it back over to the back. This is going to be a number 2 up here. And down here about clues about the past, same organisms, different continents. That's going to be a number 2. Okay, now I'm switching back to my highlighter. Evidence from the rock record, fossil record, and ancient climatic zones led scientists to conclude that the continents have moved. Okay. So, evidence from all these things, continent moved. Well, the continent move is continental drift, and it used to be called Pangea. Wegener hypothesized that the continents move, and there are many different pieces of evidence. So I'm going to highlight the numbers, because I don't want to necessarily list every single piece of evidence, but I just want to say that there is evidence. There are different types of evidence. Okay, I noticed that how fossils form and relative dating, we didn't highlight anything. Let's see if there's anything super important here. We do want to know how fossils form, that they get buried in sediment, the minerals seep in, the fleshy parts decay, and a fossil or imprint gets preserved, and that's the hard parts like the bones or hard cartilage. So that's important for me to know, but it's not going to fit in my summary paragraph, because what we really want to know is the fossil record helps us understand how the Earth's surface has been changing. Okay, remember that the whole lesson is called Earth's History. So how a fossil forms is important, but it's more important that that fossil can tell us about the Earth's history. Okay, for example, relative dating. Here we go. Relative age. The strata or the layers help us guess the relative age. That's important. Let's put a star next to that. That's important for Earth's history. Okay, let's go back and read the main idea. Rock layers and fossils equal evidence to explain Earth's history. Okay, so the rock layers and fossils can provide evidence that explain Earth's history to us. Okay, notice that they keep using the word fossil, so let's go ahead and highlight fossil. Okay, can we repeat this main idea with the notes we have? So the rock layers and fossils are evidence that explain Earth's history. Let's see here. The rock record gives us clues about changes to the Earth's surface. For example, Zoop, we can guess or infer that the youngest rock is on top and the oldest rock is on the bottom, helping us date things or figure out how old they are. Those layers are called strata. Okay, let's go ahead and highlight strata. All right, let's go back here. The fossil record helps us understand what? Oh, no, let's phrase that differently. The fossil record is fossils that are found in sediment or sedimentary rock. Let's change that so we can say it correctly. A-R-Y. And now that we say sedimentary, we'll remember to say sedimentary rock. So, fossils are found in sedimentary rock and are evidence of organisms that once lived on Earth. One of the pieces of evidence that Earth is changing is that the same organisms are being found on different continents. This supports the continental drift hypothesis, that all the continents used to be one giant landmass called Pangaea, but over time they have slowly moved apart. Okay, so we talked about the pieces of evidence, we talked about the continents, Pangaea, and then we would figure out a way to squeeze in strata and relative age when we write it down in our paragraph. Okay, we will do that together on the computer on Zoom, right? So, we highlighted some important things. We put stars next to the super most important things that are here in their summary, and we put little numbers next to them so we know which ones go together. So we know that rock record clues about changes, changing the Earth's surface, and the youngest and oldest layers, or strata, help us do dating. Then we know that fossils in sedimentary rock being evidence of organisms goes along with those organisms being found on different continents. And then that transitions into continental drift. It used to be Pangaea with a big giant landmass of all the continents, but the continents slowly moved apart, and we have several pieces of evidence to make us believe that. All right, that is it for Phase 2, processing. Then we would move on and do Phase 3, which is connecting, and our Phase 4 summary. So we'll do that together. Good job persevering with the growth mindset, and roar Wildcats!